Assalamualaikum and good afternoon. This question actually I ambil daripada December 2018 past year question so you boleh refer because this like typical question yang bakal keluar kind of like keluar final lah, but final can be macam-macam sebenarnya, not only limited to this kind of question. Okay, a 7-meter long internal column, so this one is L. In a rigid jointed steel structure is required to support ultimate design load of 1600. So this one you dah ada as a load 1600, so tak payah kira lagi, tak perlu yang ultimate load equal to 1.4 GK plus 1.6 GK. Don't need to calculate anymore, just use this value as a load ataupun as a ultimate design load. Assuming that the fixity at the top and bottom of the column are restrained in position at both ends. So this one sebenarnya nak refer pada effective length. To get the factor for effective length, you need this assumption. Maksudnya in the question dia akan bagi some assumptions. What is the value of effective length? Okay, but not restrained in direction. So both of position and direction are mentioned. So it can be like sama ada dia adalah brace ataupun unbrace. Dia bukan dua-dua Sebab yang macam example number one I give you yesterday, I hope that you watched the video already. I hope that you dah ada idea actually on that part, because that question dia tak ada mention anything about position, dia just on direction ataupun on the rotation sahaja. So when the question is like that, it means that ada possibility you kena kira both brace dengan unbrace. But this kind of question dia ada position and also dia ada direction, which means you pilih salah satu depends pada dia punya fixity. Bukan pilih lah, maksudnya kita akan tengok fixity dia, refer to the table which one yang comply with this kind of condition. Show whether the section 254-254-167 UC is adequate. Okay, so this question are different. For example, number one, dia bagi you section, which means that you can just use this section, no need to try an error. Okay, tak perlu try. Kita ambil je section ni, check. Kalau tak okay, then it is not okay lah what to do. Tak perlu suggest any section. First, what we need to do, kita cari dia punya normally apa yang kita buat, kita kira loading, but since the loading is already given, so kita tak payah lagi calculate the load. We can simply write as a load equal to 1600 kilonewton. Okay, so that is the axial load. Kita kena cari dia punya effective length. To find the effective length, kita kena tahulah berapa factor that it should be yang kita kena guna. Okay, factor berapa factor. And to find that, kita akan refer to table. This table, you have this kind of table. Okay. So kita kira effective length dulu. So LE equal to something darab dengan L lah. Okay, something tu apa? Kita nak tengok dia punya which one daripada 7 ni. Okay. Fixity at the top and bottom of the column are restrained in position at both ends. When it says restrained in position at both ends, okay, obviously you akan nampak effectively held in position at both ends. So maksudnya memang ini adalah untuk brace column, because kalau you tengok unbrace, effectively held in position dekat one end, but the other end tak ada satu pun yang held in position, but the other end is not held in position. This question, condition dia memang brace lah, antara empat ni lah. Which one we don't know. Then we look at the direction. Not restrained but not restrained in direction means that both ends not restrained in direction. First one is restrained in direction, so obviously this one bukan. Partially restrained, bukan. Restrained in direction at one end sahaja, bukan. Not restrained in direction at either end means that both end not restrained in direction. So this is the one, 1.0 L, 1.0 Allah. So 1.0 darab 7 meter, you get meter jugalah. So that is the effective length. Kita akan kena tengok dia cari PY. Okay, maksudnya we don't know the value of PY. Kita kena tahu lah PY tu 275 ke 265 ke. PY is still strength. So we know that kita punya section adalah 254 times, I tulis dulu, 167 UC. So this is the section yang dia minta you check. So from this table, kita akan check dia punya T because kita nak tahu PY dia berapa. To check for T, you can simply tengok pada table properties ni. Okay, I ada bagi kan. So you boleh tengok the one yang dalam A4 size, that one bigger. So I highlight the one yang, so this is the one. So we need the value of T, 31.7. The value of T of the flange thickness is 31.7. So what does it mean from this 31.7? Look at this table pula, design strength PY. So obviously that 31.7 is dalam lingkungan inilah because dalam lingkungan is 17 sampai 40 Sebab ini 0 sampai 16. 12 sampai 40 adalah 265. 31.7 is between 17 to 40. So PY is 265. Okay, which means that this one is more than 16 mm. Okay, so PY is 265. And then we can calculate the section. We need to calculate the section classification. Kita nak classify our section. Find the B over T and D over T. This ratio yang kita perlukan. So, kita refer again to this table to find B over T and D over T. So, ratios for buckling for flange is 4.17 and for web is 10.4. Right down here. And then to check the section classification, we need to look at this table. And we know that if let's say kita nak check for column, kena tengok yang ada compression lah. So this one is compression, this one of compression. Sebab B over T kan, memang B over T for beam and column you pakai yang sama. Row yang sama ni B over T. But for beam you akan pakai this one. Okay, but and then for column you pakai yang bawah ni. Okay, because of compression adalah column So right now, D over T and B over T. Okay, so you nampak kat sini ada constant. So kita kena kira constant dulu lah. Kira constant. Constant equal to square root 275 divided by PY. So 275 divided by PY is 265. I remind you all walaupun you dah macam rasa macam kalau katakan you buat beam, you memang tahu 275 bagi 275 square root dia memang 1. And then you tak tulis langsung, this thing ada marker So every steps of calculation, you really need to include in your jalan kira and everything because of it will be counted as a mark. This one is 1.019. We have the value of constants 1.019. Okay, 1.019. Obviously, kalau 9 darab nak 1.019, dia akan 9 point something. And this one, 40 times 1.019 become like 40 something kan. So value dia besar lah. Which means that it will be less than 9 constant and also 40 constant. This one tak payah risau sangat lah sebab dia memang selagi dia masih plastik compact, semi-compact dia memang 40 constant. But this one dia ada beza sikit like 9, 10 constant, 15 constant, 9 constant. But doesn't matter you dapat dalam any of these 9 constant ke 10 constant ke 15 constant ke doesn't matter as long as dia tak exceed this 15 constant. Sebab kalau dia exceed 15 constant maksudnya dia adalah slender. Column kita just make sure dia not slender. Bila dia slender, when you going to calculate for PC, which is the compression resistance yang last kali yang PC equal to AGPC tu, you must make sure that dia bukan slender. Kalau dia slender, formula dia bukan AGPC. Formula dia will be different. Okay? So this one will be less than 9 constant and 15. Sorry, 40 constant. 9 constant tadi. So 9 times 1.019 is, it will be 9.171. And 40 constant is with 40.76. Memang obviously lebih rendah. Section ni is not slender, tu je kita nak check. Kita check di plastik ke or semi-compact ke. So dia bukan slender. Kita nak cari PC. PC ada dua. Satu PC adalah compression resistance yang PC equal to AGPC tu. But the other PC adalah small PC which is compressive strength. So for compressive strength, you kena check in both axes, XX and YY. Kita check XX, kita check YY. So I suka buat sekaligus so that lebih cepat. RX, dapatkan RX because we need the radius of gyration in order for you nak calculate the slenderness ratio, because you know the formula for slenderness ratio is effective length divided by radius of gyration. So kita check dulu RX and RY for this section. Radius of gyration, XX is 11.9 and YY is 6.79. 11.9 and 6.79. Noted also the units is in centimeter. Dalam structure pun if you look at like whatever yang you pernah calculate sebelum ni, it is very jarang lah kita pernah calculate benda-benda dalam centimeter. Normally kita akan convert to millimeter ataupun meter. Okay. Kita tukar dia into millimeter which is 119. And this one also 67.9. Dan kita boleh proceed kira slenderness ratio. So to calculate for slenderness ratio, you need to know the effective length. So effective length kita ada calculate masa awal tadi, depend pada fixity of the end condition of the column. Fixity dia macam mana. So here we have that 7 meter. Kita calculate awal tadi. Okay, when we going to calculate for this one, effective length. So RIC you dah tukar jadi mm. So you punya effective length also you kena tukar dia in millimeter. Okay, 7,000 millimeter divide by 119 millimeter. Sama juga kat sini. 7 meter tukar jadi millimeter. And okay, so you're going to get some values here. Kanat dah jawab dah. Fatin, you tolong kira for Y. XX, okay, 58.824. Okay, thank you. Kanat, 103.093. Okay, thank you. Okay, so millimeter pangkal slenderness ratio dia tak ada units. Okay, no units. So inilah yang jawapan yang paling kelakar semalam I tanya. Masa I tanya dalam attendance yang you bagi dekat I tu, yang I tanya mana satu table yang you nak refer to for XX if let's say the thickness is 40 plus. Okay, jawapan macam-macam sampai table D lah, table E semua keluar. Ini yang I nak explain betul-betul lah. So, benda yang paling important, okay, which table yang kita nak pakai, because we have like curve A, curve B, curve C and curve D. Okay, table apa maksud saya ni, yang table ni, compressive strength ni. Table inilah maksud saya, dia ada curve C, ni curve C. Dia ada curve B, curve A, curve D. Okay, so this curve, mana satu kita nak refer for this question? Since the thickness, our thickness is only this one, 31.7 mm. Jadi kita tengok pada ini, strat table selection. Kita nak select which one Okay, you can ignore this 27 whatever ni because this one I ambil daripada final year punya examination. But dia curve A, curve B and curve C, curve D. Ignore whatever above there sebab kita tak ada hollow section ni, hollow section tahu lah kan, hollow section ni, hollow, tengah-tengah hollow. So you punya like column macam tu. Tengah-tengah kosong. Roll I section dia panjang. Okay, but kita punya adalah H section. Dia lebih kurang lah. Ini dengan ini lebih kurang sama. So nama dia H section. So kita pakai roll H section. When roll H section, since T is 31.7 mm only. You tengok dekat sini, obviously dia ada up to 40 mm and over 40 mm. So 31.7 mm is up to 40 mm sebab dia tak sampai 40 mm. 0 up until 40 adalah pakai XX curve B, YY curve C. Kalau over 40 macam soalan saya semalam, it should be curve C. Okay, sebab dia over 40 mm sebab dia 41 point something, I lupa berapa, 41.3 kah, and I minta for x-axis, so it should be curve C. So here we use curve B sebab T adalah 31.7 mm. So for this 31.7 mm curve B, for x-axis, okay, kita hafal lah sebab tak nak refer lagi dengan benda ni, kita dah tahu. X-axis curve B and for y is curve C. So maybe we can write like from table curve B. Okay, PC ni adalah compressive strength is equal to berapa. Okay, kita nak cari. And then for y from table curve C. PC equal to berapa? And we need to find this value of PC based on the slenderness ratio and also PY, which is still strength. Still strength kita dah tahu 265. And the slenderness ratio for x-axis is 58.824. Okay, so kita dah tahu curve B. Kita cari table curve B. So kat sini, I ada provide table curve B. Okay, you boleh tengok yours. Ada bagi yang size A4. We have our slenderness ratio which is 58.824. Kalau you tengok dekat sini 58.824 tak ada. Tak ada dalam table ni. You just ada 58 sampai sebab 58.824 is between 58 dengan 60. So 58 dengan 60 here. And then also, kita tengok pada PY which is 265. So 265, tengok at the same row and column here, 217 and 214. So this is the value that we want. Maksudnya value you akan jadi in between this one lah. Berapa value dia, antara 214 ke 217. Okay, maybe we can write it down like 58 equal to 217. Okay, the value that we want is 58.824 is something that we don't know. So I put PCX, okay, X, because of X axis lah. You can put like PCX, PTU. Cakap you tahu tu apa. And then we have like 60 equal to 214. I lebih, sorry I mesti explain semalam, I lagi suka macam 58.824 minus 58. Compared to I buat 58.824 tolak 60. Dia macam jadi menyusahkan I untuk mengira sebab I kena tekan calculate. PCX minus 217. So bila 58.824 you dah tolak kat sini. Sini dah tolak yang ni. Yang PCX minus yang sebelah kanan ni pun sebab dia equation you kena tolak bahagian yang sama dengan atas ni juga Ambil 60 minus 50 point equal to 214 minus 217. 0.824 sama dengan PCX minus 217. 2 equal to negative 3. Senang kira. So kita boleh cross multiply this value. Ni kena tekan calculator sikit lah. Patricia 172.222 kurang tepat you. Okay, first kita darab silang ni. Negatif 3 ni darab 0.824. You akan dapat negatif 2.472. And then sama dengan 2 PCX. Negatif lagi sebab negatif 217 darab 2. Negatif 434. This one you move here so jadi plus kan. Negatif 434 move there. Move to the left. You akan dapat 431.528. Okay, sama dengan 2 PCX. Okay, and then PCX is equal to you bagilah dengan 2. Which is you dapat 215.764. 215.764. So kalau you nak tak tengok macam if let's say takut ada salah kira ke, macam kita pun kadang ada salah kira. You boleh tengok, you boleh check, tengok dekat sini lah. So number dia mesti in between 214 sampai 217. Okay, kalau you nampak nombor dia dah keluar pada nombor ni, mungkin ada some typing error ataupun miscalculation . Okay, unit dia is Newton over mm square. Mana dapat unit, you tak pasal susah fikir macam mana lah mesti kira dapat unit. Kita tengok pada ni, macam mana dapat unit. Obviously kita tengok pada this one, dia dah beritahu dalam you punya table sendiri. It mention that PC Newton over mm square. So kita kena check for YY pula. So kita tahu it is curve C. Value for slenderness ratio is 103.093. So here is curve C. So slenderness ratio is 103.093. 103.093 tak ada juga kat sini. You know that it is between 102 sampai 104 lah. And also your PY should be 265. So dia dalam this 265 column and 102 104 punya row. Sama juga method, the way we calculate this one going to be 102 equal to 120, and then our slenderness ratio value tak tahu, PCY, and then 104 equal to 117. So kita tolak. Sama je cara 105.9 tolak 102. PCY tolak 120. And 104 tolak 102. Sama dengan 117 tolak 120. Mudah kira. So 1.093 equal to PCY minus 120. 104 tolak 102, 2 sama dengan negatif 3. Okay. Boleh terus calculate. Dayang Azizah 118.361. Oi, pantainya kau kira, aku tak habis kira lagi. Okay, tapi betul Okay, so negatif 3 darab 1.093 you akan dapat 3.279. Negatif, don't forget, equal to 2 PCY tolak 240. We move it to negative 240 to the left. It become plus. Okay, so you dapat 2 PCY equal to 236.721. And then you just divide by 2, you will get 118.3605. 361 lah. Okay. Thank you . So 118.361. 118.361 unit masih sama Newton over mm square. So kalau you tengok value ni, PCX, okay, tinggal letak PCY, PCX macam lagi senang tengok. PCX dengan PCY, maksudnya PCY tu untuk YY lah, PCX tu X-axis . PCX dan PCY kita akan ambil value yang lebih rendah untuk kira compression resistance, which is PC equal to AG PC. Okay, you nampak PC yang ini ni, okay. Ni adalah in between salah satu ni lah, yang mana satu you nak pilih. Kita akan ambil value yang lebih rendah. Because value yang lebih rendah contohnya, kalau 215.764 ni maksudnya PC dia compressive strength dia tinggi, arah X. Tapi compressive strength arah Y dia weaker, which is 118.361. So kalau you letak loading lebih, maksudnya you letak loading comply dengan PCX saja, you tak consider about PCY, nanti arah YY akan fail. Sebab you punya column macam ni, tegak. Dia going to be like this. Okay, dia tegak macam ni. So arah XX okay. Tapi arah YY tak okay. So arah YY fail. Arah XX okay. Kita tak boleh design macam tu. We must make sure that both sides, maksudnya both axis okay. Okay, so kita akan ambil value PCY, maksudnya strength yang lebih rendah untuk kita calculate to be compared with the axial load yang acting on the column. So using this formula to calculate the compressive resistance, okay, AG, we need to find AG. So AG ni apa? AG is, so this is the section that we are talking about, 212 centimeters square. AG is equal to 212 centimeters square, or when we calculate, we need to tukar dia into millimeter square. So 212 centimeter tukar kepada millimeter darab 10, so maksudnya darab 10 sekali. Because of the centimeter square, maksudnya kena 2 kali darab 10. Okay, so it become 21,200 millimeter square. 21,200 mm square. We can simply multiply it with with PC Y ni lah, 118.361. So you akan dapat jawapan dalam Newton.
2509.353.
Point. You dah kira dalam kilonewton
Dah.
Ini dalam kilonewton You akan dapat macam ni lah. 2509 253.2. Compressive resistance 2509.253 kilonewton. You dah dapat. You kena comparekan dengan you punya loading, maksudnya axial load lah. Because this one is the compressive resistance oleh section. Because section you boleh resist 2509.253 kilonewton. Tapi berapa loading yang acted on the column, you tak tahu. So, kita tengok balik soalan, berapa dia bagi. So, it is axial load 1,600 kilonewton. So, kalau compare, you akan nampak PC ni lebih besar daripada 1,600 kilonewton. Maksudnya okey lah. Maksudnya kolom ni boleh resist loading sebanyak 1,600 ni. Sebab loading dia sebenarnya lebih besar daripada boleh resist. Siap. Bye everyone.